Which one of the following is not a local or temporary base level of erosion for trunk of parent system stream? Sorry. So not a local or a temporary. Okay, not is very important here. Okay, so if we look at this, if some river is flowing like this, okay, parent stream is flowing like this, and we get a dike like this. So this dike or sill, okay, will affect the base level. Okay, now if dike is not there, if we get a lake in between, it is also local or a temporary base level erosion, because below that erosion, below that up in the upstream erosion will not take place. Now next is dam. If we construct a dam, the natural base level of erosion is disturbed now. Okay, and the upstream deposition started now. Due to that, the base level of erosion is rises. Okay, and in the downstream flow of the stream is increase or decrease depend upon that. The base level of erosion also changes. And if the water is choked somewhere, and due to that the sediment supply and the speed of the water is reduced, so it will affect the base level of erosion. Next option is tributary. Okay, actually tributary is all the tributaries when meet, it will increase the flow. Okay, and due to that the temporary base level of erosion is not affected. Okay, it is not a local or a temporary base level. Yeah, actually the water when two tributaries meets, and there is decrease in speed but increase of volume of water. Okay, but it is natural. Okay, so in this way we can proceed. Okay, remember this. Which one of the following is not a local or a temporary base level of erosion for trunk or a parent stream? Okay, when tributary stream meet the this main stream, it will not uh, it is not a local or a temporary base level. Okay, base level of erosion. Okay, because there is no barrier. No, it is not a barrier tributary. Okay, in this way we can approach this type of question. Okay, so in this question, diurnal tide in each tidal day. Okay, first of all, we should know this question is related with basically the tide. Okay, and there are different type of tides, and if you know those things, you can answer this type of questions. Okay, actually the tides are divided on the basis of two things. Okay, first frequency, how frequently it come, and second is position of earth, sun and moon, combination of all these three. So in this we get spring tide and neap tide. And on the basis of frequency, semi diurnal and mixed. Okay, these are the three. Okay, in semi-diurnal, what is going to happen? Two equal high and low tides, and approximately take 12 or 25 minutes, and they are generally comes along the eastern African coast and Bay of Bengal. Okay, with respect to India, Bay of Bengal. Okay, important for us. Next is diurnal, and in that okay, uh, next is diurnal. So in this 4 tides in a day, but 2 tides by sun and 2 by moon. This condition happen when sun, moon, earth all are in same line. Okay, and we call this position as a SY, ZY, GY. And they are further subdivided. Okay, I'm not going in that detail. Next one is mixed tide. Okay, mixed tide means unequal. Okay, in this two high and two low will form, but unequal height. Okay, and these tides we observe generally along Gulf of Mexico, Caribbean Sea. Okay, southeast Brazilian coast. Okay, where we get these mixed tides. Okay, and with respect to our question, the question is diurnal tide in each tidal day refers to we know that the too high and too low. So our option is one high, one low, cancel. Where a large high and large low cancel, and this is our right answer. Okay, too high and too low, total 4. So in this way we can approach this question. So in next question, under invariant moisture condition, maximum relative humidity in India is exactly. I don't know the concept related with this right now. If anybody knows the proper concept, just mention in detail in the comment box. Okay, for others, so that they can also get the benefit. If you will get the proper explanation, I will explain this question in the next video. In which one of the following layer temperature decreases with latitude? This question is very simple. yourself just mention the answer in the comment box. Okay, if you know the idea of the layer of the atmospheric layer, and in which layer the temperature is decreases, okay, with altitude. Okay, remember this. So the next question is, which one which among the following is primarily a cyclostrophic flow? Okay, if you know the meaning of cyclostrophic flow, then you are able to answer. Okay, it is a circulation pattern. Okay, and it depend upon the you know atmospheric pressure gradient and centrifugal force. And near equator, Corliss force also fit. Okay, Corliss force. And they are generally, you know, cyclic, cyclonic, and anticyclonic. Okay, uh, like tornado, dust, devils, water spouts. So in this case, the low pressure gradient. Okay, low pressure system will develop, and curvature of the airflow is also small. Okay, and it can be clockwise or anti-clockwise. These because it develop on a small scale. Okay, but in anti-cyclonic, particularly it is related with northern hemisphere and southern hemisphere. Okay, and here it is like this, anti-clockwise, and it is clockwise in southern hemisphere. So basically, there are many more things related with the cyclostrophic flow, with this, but I'm not going in their detail. Okay, because uh, it need the whole concept. If you need the whole concept, just mention in the comment box so that I can make video accordingly the topic wise. Okay, so our correct answer is anticyclone. So in the next question, if the temperature in the atmosphere decreases at a rate of 11 degree Celsius per kilometer with height, a saturated air parcel would be. So first we should know the concept of Laplace rate, saturated air parcel, and all those things. Okay, but I'm not going into that detail in this video. Okay, uh, I'm just giving you some number if it is like that. Okay, for stable condition, if temperature is 4 degree, per kilometer. For unstable condition, 11 degrees Celsius per kilometer. Okay. In this way, you can approach this question, because there are some other things that I want to tell, but I don't want to tell in this video, because this concept need the whole steps, okay, so that the clear picture of this concept will be clear. So I will make one diagram, okay. With respect to that, I will explain this. Okay, till then, just remember this. So our option is 4 is the right option. If it is in between these two, 4 degree to 11 degree, we call it as a conditionally stable or neutral, okay. So now in the next question, which one of the following is the correct statement for geoid and spheroid? And there is one more term, okay, which we call it as a ellipsoid. So what is the difference between these three terms? Okay, I will explain this. So spheroid means a solid where rotating an ellipse about either the major or minor axis. Okay, just remember the definition. Okay, spheroid is a solid generated by rotating an ellipse about it either a major or minor. If we rotate, we'll get some shape like this. Okay, and ellipsoid is a solid for which all plane section through one axis are ellipse and through other are ellipses or circles. Okay, we rotate, one axis will play as ellipse and another axis will play as a circle. Or okay, now if there is one condition, if any of the two, okay, in these three axes, if two are equal, then figure become spheroid. If all three are equal, then we call it as a ellipsoid, and the term geoid is equipotential surface, okay, equipotential gravity surface of earth at mean sea level. We call it as a geoid. And there is one more condition at at any point, okay, it is perpendicular to the direction of the gravity. Okay, so our correct answer is this. Gyroid is equipotential, but spheroid is not equipotential. Okay, there is one more concept you should remember in this, that this ellipsoid, this spheroid is formed from the ellipsoid, so it is a mathematical, simple mathematical definition. Okay, and it is described by two parameters we used into the okay, and can be sensed by instrument. We can use instrument to sense this. Okay, oh sorry, cannot be sensed by instruments. Okay, we did not use any instrument to calculate this. Okay, for calculation. Okay, instrument. Okay, with respect to gyroid, it is a physical definition. It has a mathematical, it has a physical. Because we use gravity in it, na. Here describe only two, described by two parameter. Here we can use infinite number of parameter. Okay. Okay. And we can use instrument to measure or okay. So in this way you can approach this question. Okay. So in the next question, arranging from older to younger geological age, which one is the correct sequence of this continental broken episodes? Okay, so if you don't know the name of the rest, but everyone should means everyone this continental drift theory, and in that we know that Pangea word used. Okay, so it means Pangea is a younger. Okay, and we have to write from older to younger. It means this Pangea will come in the end. So our option 4 is the right option. Okay, and you just remember this. Okay, that Colombia, Rhodesia, and what are the things that are related with this particular setup. You should know the idea of those things. Okay, what is going to happen in Pangea? Okay, what is going to happen during Rhodesia, Colombia, or so if some idea about this, and with respect to not with respect to the continent, these continents are touching with this is no, with respect to mineralogical point of view, deposits and other things. Okay, what is going to be happen during Pangea break? Is there any deposition took place in terms of sedimentary, igneous or metamorphic, or during Rhodesia or Colombia? So that you can picturize the whole picturize the things in sequence. Okay,